Welcome to Gateway Lectures. Here we have a good numerical on strength of materials on a hinge problem. Let us go through the question. A pole supported by a pin at C. So there is a pin, nothing but a hinge at C point, and it is a pole. BC is a pole, and a steel wire AB is as shown in the figure. So it is supported by a steel wire AB. Okay. Here we are, and if the wire has a diameter of 5 mm, so this wire has a diameter of 5 mm. Then how much it stretches when horizontal force of 1.2 kN acts on the pole. So this is actually a basic question. Here if you can observe on the pole, these forces are non-concurrent and coplanar. So they lie in the same plane, but they are non-concurrent. These forces doesn't meet at a point actually. So for these type of questions, whenever you see non-concurrent and also coplanar, we need to apply the basic equilibrium conditions like sigma fx is equal to 0, sigma fy equal to 0, and sigma moment about any point on the body or external to the body as equal to 0. So how much it stretches when horizontal force 1.2 kN acts at a pole as shown in the figure. So for this initially we have to take sigma m about hinge. So if there is any hinge, the moment about the hinge will be equal to 0. So here the hinge is nothing but point C, and that should be equal to 0. So if you apply that 1.2 kilonewtons into the 1.5 meters at the distance, it is in clockwise direction. We have considered it as positive. If you take T as a component, so this will be T cos 30, right, and this will be T sin 30. So only perpendicular component should be taken in moment. So T sin 30 into the distance is minus, since it is anti-clockwise, the distance is T sin 30 into the distance is 1.5 plus 1 meter extra. So it will be 2.5, and mass of the pole will be at the center, but that will be passing through the point C, so we need not take moment, and this will be equal to 0. From that we will get the value of T as 1.44 kilonewtons. This is the value of T. And T was known, that is a force being acted in the string or the steel wire. For that steel wire we need to calculate length. To calculate length we need to apply right angle principle, and it says that this is 2.5 meters and this is 30 degrees, and we need to calculate this. For this we will apply cos 30. Cos 30 is equal to adjacent upon hypotenuse. From that we will get x is equal to 2.5 upon cos 30, and that value will be getting as 2.88675 meters. That is the value of x, nothing but the length of the steel wire. So length is known, force is known, area. Coming to area is equal to pi by 4 into d. Diameter is given as 5 mm. So nothing but 0.005 meter square, and the value of area will be getting as 1.9635 into 10 power minus 5 meters square. So tension is known, length is known, area is known, Young's modulus is known. So nothing but the stretching, whatever the stretches, delta L is equal to PL upon AE. We know that P nothing but here tension, that is 1.44 kilonewtons, and the length is given as length we found out to be 2.88675 meters, divided by area is 1.9635. 1.9635 into 10 power minus 5 meters square. Young's modulus is 200 gigapascals, so it is 200 into 10 power 9 pascals, nothing but 200 into 10 power 9 Newton per meter square. From that we will get the value. In meters. It is 1.05855 into 10 power minus 3 meters. So when we get the answer in mm, we multiply it by 1000, we get the answer as 1.05855 mm. And also when in these type of questions, they will be mostly filling the blanks. In the fill in the blanks, they'll ask correct to 1 decimal and correct to 2 decimal. So how we will see how to correct the thing to 1 decimal and 2 decimal. Here to correct to 1 decimal, suppose we take 1 decimal place. To do 1 decimal, first we need to write the integer value 1 point. If you take the decimal value, it is 0585 so on. So 0 will be the actually 1 decimal place there, and 0.585 is greater than 0.05. So we need to take 0.01 here, 0.06 here. So we can just write 1.05, or also we can also write nearly equal to 1.0 if you have to correct to 1 decimal place. If you were to correct two decimal place, here comes the important thing. If you come to two decimal place, we need to write 1, and the second two decimals will be 0.5. So the 0.5 is greater than 0.05. So we need to take 0.06. This is corrected to two decimals. So this will be the answers when they have asked to make correct to two decimals and one decimals. Thanks for watching. Still we'll do many numericals in this. This question is an actual easy question, but these type of questions will be asked in exams like ISRO and exams like BARC, where we'll have very less time to do this, to solve this type of questions. And also mostly if we consider BARC, there in online exam calculated will be allowed. So mostly these type of questions will be in BARC. In ISRO also there can be questions, but the calculations will be made simple with the data. So they will change the data so that the calculation gets very simple. So these type of questions should be practiced more. So to take the moment reactions 0. So how we'll get the idea to take moment equal to 0, because here it is a non-coplanar concurrent system. So for wherever you see non-concurrent coplanar system, wherever you see non-concurrent coplanar system, we need to use the three equilibrium conditions: sigma fx is equal to 0, sigma fi equal to 0, and also sigma moment about anything is equal to 0. If you find coplanar and concurrent, then we can use things like triangle law, or else we can use things like Lamy's theorem, etc. So these type of questions, by seeing the question itself, we can get the idea to apply sigma fx or sigma fi, or moment about any hinge point, moment about any point. Here it need not be a hinge point. Actually, if it is an equilibrium, it can be any point. So it can be applied. Thanks for watching.